Hi guys, welcome to the solutions for the 9.4 through 9.6b practice test. At this point in your math career, you should understand that these practice tests are so important and they're great ways to study for the test. So that's why we give you the solutions. We like to post them on YouTube. So use these as a study guide and really try to understand what's going on in each problem. And if you don't, go and see your teacher before the test, because these tests are highly weighted and they affect your grade a ton. Alright, so let's get started. Alright, so number one says evaluate the expression. Now what does evaluate mean? It means do all math. So whenever you're talking about evaluate, you're going to do all the math you possibly can. You don't want to leave any number unmultiplied. You want to reduce everything. You want to just do as much math as you possibly can. You don't want to leave any exponents. You just want to completely take care of it. Alright, so when I'm looking at this thing, the first thing I'm seeing is a negative exponent. I do not like negative exponents. So how do I get rid of them? Well, yeah, I make a fraction out of it. So really what I have to do is send this 2 to the negative fourth downstairs, but when I send it downstairs, I have to get rid of that negative. That's why I send it downstairs, because this is another way of saying 2 to the fourth is in the denominator. Now I do need something in the numerator, and that is going to be a 1, because there's really kind of a 1 times this, and that 1 will just stay up top. We just never write that 1. Now, there's lots of ways to do this. So this is 1 over 2 times 2 times 2 times 2. And I like to multiply kind of 2 pairs at a time. So this is 2 times 2 is 4, this is 2 times 2 is 4, and then that gives me 16. So my final answer for number 1 is 1 over 16. Alright, the next one I want to evaluate, so I want to do all the math. Now I'm noticing I'm multiplying, and when I multiply fractions, whether they're fractions with exponents or variables or whatever, I just multiply straight across. So what I'm going to do is I'm going to multiply these 1's together, and then I'm going to multiply these denominators together. So when I do that, I get 1 times 1 on top, and I get 4 to the negative fifth times 4 to the 8th on the bottom. Now, I do see a negative exponent, and don't let that scare you. We'll take care of it at the very end. Now, let's just do the multiplication. Well, 1 times 1, that's obviously just 1. Now, what's the rule when we have the same base and we're multiplying? Well, yeah, we add it. So this is going to be a negative 5 plus 8. When you have the same base and you're multiplying, you copy the base and add the exponents. Alright, so let's clean this up a little bit. Well, what's negative 5 plus 8? Yeah, that's 3. So this is going to be 4 to the third power. And this now is going to be 1 over 4 times 4 times 4. Well, 4 times 4 is 16, and 16 times 4, I believe, is 64. So our final answer is going to be 1 over 64. Okay, on number 3, it's saying that we want to write using only positive exponents, so we don't want any of these negative exponents. Now, I'm looking at this thing, and I'm noticing this negative 3 exponent is only connected to the x because there's not parentheses around the 8x. It's only connected to the x. So the 8 is actually going to stay on top because it is not affected by the -3 exponents. The x, though, is going downstairs because it's a negative exponent, and it's now to the 3rd power, because when we bring it down, we get rid of the negative. So the answer would be 8 over x to the 3rd power. All right, so number 4, we kind of have 4 little mini problems here. We have the 15 over 3, we have the d's, and we have the e's. So we're going to take care of each one of these separately, and then we'll clean it all up at the end. All right, so the first one, 15 divided by 3, that's pretty easy. That's going to be 5. Now, the d's, well, what do we do when we divide? We copy the base when it's the same base, and then we subtract our exponents. So this is going to be 4 minus 9, and then likewise here with the e's, we've got 5 minus 5. Now, I'm just going to bring that 5 down in my answer right here because I know there's nothing that's going to happen to that. But I've got to clean these things up a little bit. So let's see here. This is going to be D. Actually, I'm going to erase that 5 for a second because I'm going to have to do something with it. So sorry about that. All right, so 4 minus 9. What's 4 minus 9? Well, I believe 4 minus 9 is -5. And what's 5 minus 5? Well, I know 5 minus 5 is 0. Okay, so we're ready to clean this whole thing up. We've taken care of each one of these colors here, and now let's put it in an answer. Well, whenever I see a negative exponent, I know I have a fraction. So since this d to the -5th is its -5th, I'm going to put it into the denominator, and when I do that, it will eliminate the negative sign because I want only positive exponents. Now the 5, I put it there, but let's put the 5 just on top. It's just 5, it goes on top. Now, e to the 0, or anything to the 0, is just 1. Now, we don't need to put that in our answer because we already have a 5 up here to kind of hold the place. I guess we could say 5 times 1, but 5 times 1 is just equal to 5. So we just want to put it in the simplest of a form we can, so I think I'll just go ahead and erase that 1. I don't need to put it in there because if I did, it would just be 5 times 1, which would still be 5. So this is the easiest way that I know to write the final answer. Now, let's take a look at the next problem here. It's asking, can a number raised to a negative power ever be greater than 1? If so, give an example. If not, explain. Well, if you had a number like 5, and you're raising it to the, say, -2nd power, that's going to be 1 over 5 to the 2nd, which equals 1 over 25. Now, so it looks like, can a number raised to a negative power ever be greater than 1? Well, in this case, it would be no. But let's see an example like this. What if we have 1/2 raised to the -2 power? Now, let's see what happens when we do that. Well, what I would see here is I would see an exponent of 1 and 1 here, and I'm raising powers to powers. So I'm just going to multiply this. So -2 times 1, so this is 1 to the -2 power. And then this is -2 times 1, so this is 2 to the -2 power. Now, let's clean this up a little bit. Well, what do negative exponents mean? They mean flip me, basically. So if this 1 right here, if I want to get rid of this negative 2 power on this 1, I'm going to put it downstairs. So the 1 is going to come downstairs with the 2, and then we'll just erase this negative. So to get rid of this negative, we'll put it in the denominator to get rid of it. But this one is already in the denominator, and it's already negative. So how do we get rid of it? Well, we bring it up. And so this will give me 2 to the 2nd power because I brought it up to get rid of the negative because it was already down. And when I bring it up, I get rid of the negative. Whenever you switch up or down, you're getting rid of the negative. Now, let's clean this up. 2 to the 2nd is 4. And let me pull this over here a little bit so I'm not in that problem. So 2 to the 2nd is 4. 1 to the 2nd is 1, which is 4. And that is a number that's greater than 1. So here's how I would summarize this answer, ladies and gentlemen. I would say, can a number be raised to a negative power ever be greater than 1? I would say yes, if the base is less than 1. And what do I mean by that? Excuse me. Well, here our base is greater than 1, so when we did a negative exponent, we got an answer that was less than 1. Here our base is less than 1, but when we did a negative exponent, we got an answer that was greater than 1. So yes, if the base is less than 1. Alright, is this number in scientific notation? No way is it in scientific notation because this number right here is not between 1 and 10. So you would say no, 0.25 is not between 1 and 10. And I don't think you have to put it on the line here. Write this number in standard form. Well, that's easy. I just copy down the 8, and I know the decimals right here, but it's 10 to the 6th, and since it's a positive 6, I'm going to scoop-de-loop 6 to the right. So 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. So it's an 8 with 6 zeros after it. What is that? 5, 6. So I believe this would be 8 million. All right, now we want to write this answer, number 8, in standard form. Okay, same thing. So now I'm going to copy down the 5.3. Now, since this is a negative exponent, I'm going to scoop-de-loop. That's a movement of the decimal 4 places to the left. So 1, 2, 3, 4. So I'll fill in those scoop-de-loops with zeros, and my answer would be 0.00053. All right. The average distance from the Earth to the Sun is about this many meters. The average distance to the Earth to the Moon is this many meters. Which is closer to the Earth, the Sun or the Moon? Okay, well, let's take a look. So the Sun, let's put these in standard form, okay? So we have 1.5 times 10 to the 11th. Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I believe we would fill in 10 empty scoop-de-loops here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now the moon is 3.84 times 10 to the 8th. So it's 3.84 times 10 to the 8th. So 1, 2, 3, 4, 5, 6, 7, 8. So there's a 0 here, 0, 0, 0, 0, 0. Let's see here. Well, obviously the sun is much further away from the Earth than the moon is. I think we'd burn up if we weren't, but let's just see what these numbers say. So this is hundreds. This is thousands. So the moon is approximately 384,000 meters away from the Earth. Now the sun, let's see here. So this is 1, so hundreds, thousands, millions, billions, and the sun is approximately 150 billion units away from the Earth. So it's obviously going to be the sun, and the explanation would be this number right here is much larger than this number right here. Okay, so what's the error here? I think it's pretty obvious. It's a negative exponent, so what they should have done, not dumb, but they should have scoop-de-looped the other way. So they need to scoop-de-loop to the left, not to the right, because it's negative. So it would be 1, 2, 3, 4, 5. So in your answer, you should say something about they moved the decimal in the wrong direction. It should have gone to the left because the exponent is negative, and the correct answer should be 0.000051. So the 4 zeros need to be in front of the 5-1, not after the 5-1. Okay, so we want to write number 11 in scientific notation. Okay, so we need to put that decimal right here, because if we put the decimal right there, it'll make it a number between 1 and 10. So the decimal is currently right here, and we're going to move it to right here. So I got to be real careful and count my scoop-de-loops. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 scoop-de-loops, if I did that right. Hopefully I did. So it's going to be 3.49 times 10 to the 14th. And since it's a really big number, and whenever you scoop-de-loop this way, when you're changing to scientific notation, when you scoop-de-loop to the left, when you're changing to scientific notation, it's going to be a positive exponent. So two ways to look at this. You can think of it as a really big number gets a positive exponent, or when you move to the left, you get a positive exponent when you're changing into scientific notation. Okay, so with that kind of thinking there, I can already tell that I'm going to have a negative exponent on this one, because I'm going to have to scoop-de-loop to the right, and I'm starting with a very small number, a very, very minuscule number. And again, make sure I scoop-de-loop this one right. I think 14 was right, but who knows? I could have made a mistake. Now let's take a look at this one. So now I've got to put this decimal to make it a number between 1 and 10. That would put it right here between the 6 and the 5. So let's go ahead and do that. So 1, 2, 3, 4 scoop-de-loops. Is that right? Let me make sure. 1, 2, 3, 4, 5 scoop-de-loops. My bad. Sorry. That's 5 scoop-de-loops. So when we do that, it's going to be 6.524. And then 1, 2, 3, 4. Yeah, that's right. Times 10. And then we had 5 scoop-de-loops, but they're negative because we started with that small number. Okay, so this one we're going to multiply this out. The first thing I like to do is rearrange all the numbers. All these numbers are just being multiplied together, and there's this really cool property in math called the commutative property of multiplication, which means I can just switch all the orders around and it won't change anything. So I'm going to put the 4 next to the 1.7, and then I'm going to put the 10 to the third times next to the 10 to the fourth, and then I'll just simply take care of these two first. Well, I just happen to know that 4 times 1.7 is 6.8. And you should probably always check Mr. Roden's math. Sometimes he makes mistakes. All right? And then times, I'm going to leave an X for times because scientific notation often likes to use a times X in the final answer. And then what am I going to do? I'm going to copy down the base of 10, and since it's the same base, I'm going to add those. So 3 plus 4 is 7. Now, I always want to ask myself, is this answer in scientific notation? Well, yes, it is, because 6.8 is between 1 and 10. So that would actually be my final answer, 6.8 times 10 to the 7th power. Now, let's do this one right here. Well, let's rearrange them. So 6 times 7 times 10 to the negative 12th power times 10 to the negative 4th power. Now, what we need to do here is multiply 6 times 7. I happen to know that's 42. And then I'm going to add these exponents here. So what's negative 12 plus negative 4? Well, yeah, that's negative 16. And so I have this answer. Now, is it in scientific notation? No, it's not. 42 is not a number between 1 and 10. So I'm going to actually have to scoop-de-loop on this one spot. And then when I scoop-de-loop one to the left, and I'm in scientific notation, I have to add one positive here. Okay, one scoop-de-loop to the left equals a 1 positive on the exponents. So let's clean this up. So now I have 4.2, which is a number between 1 and 10, and then I have times 10. What's negative 16 plus 1? Well, yeah, you guessed it. It's negative 15. And there's my final answer. All right, number 15, I've set up with a rectangle, and I just put these numbers in, and now we want to find the area. And how do we find the area? Yeah, we just multiply length times width. So I'm kind of going to do the same thing I did before, but again, I'm going to put those things together. So I have 3.4 times 9.2 times 10 to the third times 10 to the 8th. Now, I'm not going to show you all my multiplication because that could get a little messy here. So what I have is when I take 3.4 and multiply it times 9.2, that answer right here is going to give me 31.28. And when I take 10 to the third and multiply it times 10 to the 8th, that's going to give me 10 to the 11th. 8 plus 3 is 11. Now, am I done? Well, no, I'm not done because I'm not in scientific notation now. So I have to change the color here a little bit. I'm going to scoop-de-loop one here, and then I'm going to add one to that. So let's write our final answer on the line over here. So it's 3.128 times 10. Now, what's 11 plus 1? Yeah, that's just 12. And there's our answer in scientific notation. And we're talking about inches, but we're talking about area. So I'm going to say it's square inches because you're talking about how many squares are inside that rectangle right there. Okay, so now I want to divide these two. When I do division, I like to use fraction bars. So I take the first kind of parentheses, 6 times 10 to the 4th, and I write it over 3 times 10 to the 4th. Now, what I'm noticing here is I'm going to kind of take care of two different problems here. I've got this problem here, and then I've got this problem right here. So this should be pretty easy. So what's 6 divided by 3? Yeah, that's just 2. And this is going to be, well, let's see, when you have same base and you're dividing, you actually subtract. So this is going to be 4 minus 4. This 4 minus this 4. So this is going to be 2 times 10 to the 0. And we've learned in our class this year that anything to the 0 power is 1. So this is just 2 times 1 because 10 to the 0 is 1. And then 2 times 1 is just 2. Now we need our answer in scientific notation. So how would we do that? Well, it would be 2 times 10 to the 0 power. So we actually want that 0 power in there today because we need to be in scientific notation. We always want to have times 10 to some power, and that power was 10. All right, I've kind of done the same thing on this one. I set it up as a fraction. All right, so the hardest part of this problem is obviously the division. So take your time. I won't do the division for you, but one thing I will say, though, is that if you have 2.3 and you're dividing by 9.2, and on your real test, you're not going to have a calculator. So if you're getting used to using calculators, you might want to practice here because you won't be able to use it on your test. So here you've got to move the decimal 1 here, move the decimal 1 here, and then add some zeros. So when you're doing this actual division, it's going to be 92 into 23.00. And now bring that decimal up and start to figure out how many times 92. We'll kind of go into all that stuff. Now, when you do that, you're going to get 0.25. Okay? So the answer to this pink problem right here is 0.25. And this is going to be times 10 to the 7 minus 5, which would be 2. Now, are we in scientific notation? Well, no, because this number is not between 1 and 10. So what we're going to do is we're going to scoop-de-loop this back to the right, not to the left. We're going to scoop-de-loop it back to the right. Now, when we scoop-de-loop to the left on those other problems, we added 1. So when we scoop-de-loop to the right, what do? Yeah, we subtract 1. So let's clean this up and put it in scientific notation for us. So, well, where did my pen go here? Let me get that. Let's clean this up. So let's see here. We'll write it kind of small. So it's going to be 2.5 times 10 to the 2 minus 1, which is just be 1. And I actually like to put that 1 there on scientific notation. Like I put the 0 here, I like to actually have the 1 there. Scientific notation likes those numbers. Okay, so for number 18, same kind of deal. They just put it in the fraction for you. Be real careful with your division like I showed you on number 17, moving decimals and adding zeros. When you do that, you should get 0.4 for this answer, and I would highly recommend you do the long division and make sure you can get 0.4 for an answer times 10 to the top exponent minus bottom exponent, -4 minus 2. So let's clean this up. So this is going to be 0.4 times 10 to the, what's -4 minus 2? Well, yeah, that's -6. Now, am I in scientific notation? No, I'm not. I need to put it in scientific notation by moving 1 to the right. When I move 1 to the right, what do I have to do with this exponent? Again, I have to subtract 1. When I move to the right, I've got to subtract 1. So what's the final answer here? Move this down. Our final answer is 4, or 4.0, but I'll just call it 4, times 10. What's -6 minus 1? Yeah, that's -7. Okay, keep going. Same thing here. Make sure you do the long division off to the side, and you can make this work. But when you do this long division, you should be coming up with 1.5. And if you can't do the long division, go see a teacher. We'll help you out with that. Times 10 to the, let's see here, negative 7 minus negative 2. See what I did here? I took this top one and I subtracted this bottom one, minus negative 2. All right, let's clean that up. So now I have 1.5 times 10. Well, what's negative 7 minus negative 2? Whenever you have a minus right next to a negative, we can add that. Copy, add the opposite, sometimes teachers say. So now this is negative 7 plus 2, which is negative 5. Now, let's look at this. Is this in scientific notation? Well, yeah, it is, because it's 1.5 is between 1 and 10. So we're good to go. This is the final answer right here. Okay, so this last one, we want to see how many of these, how many times greater is this basketball than this marble. So we know the radius of the b-ball, the basketball, is 1.143 times 10 to the first, and we know the marble is 5 times 10 to the negative first. So we're gonna divide. We're gonna see how many more times. We can do that by dividing. That's why they said use your knowledge about dividing. Alright, so we can do that. So the first thing I need to do is take this and divide it out. Again, I keep saying it, make sure you can do this, but for the sake of making this video pretty short, I'm going to tell you that that's 0.2286 times, and this is going to be 10 to the first minus negative 1. Be careful on that, guys. 10 to the first minus negative 1. All right, let's clean this up. So let's take care of this business. So I'll kind of do some work over here. So it's going to be 0.2286 times 10 to the, let's see here, these cancel out to positives. So 1 minus negative 1 is really just 1 plus 1, which is 2. Now I'm not in scientific notation, so I need to make that happen. So I'm going to move it 1 to the right, but then that means I have to subtract 1 on the 2. So let's write our final answer. Our final answer is 2.286 times 10 to the 2 minus 1, which would just be 1. And there's your final answer. You're done. Okay, hopefully this was helpful, and you are ready to take your test for real. Study hard, work on that division, and good luck to you.